let's wrap up all these reactions with the last two. The next reaction is called hydrolysis. You may have heard of the word lysis in a biology class. Lysis means to break something, and hydrolysis means to break apart using water. So this is the next one, hydrolysis. 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 Okay. What are we breaking apart? We're breaking bonds with water. All of those digestive reactions that you learned maybe in an anatomy and physiology class, where your enzyme amylase is breaking down the starch. Remember salivary amylase in your mouth and in pancreatic amylase. All of those are hydrolysis reactions. Using water, you are breaking bonds. You break bonds between carbohydrates. You can break bonds between lipids, fats. You break bonds between amino acids. You can hydrolyze DNA. You can hydrolyze RNA. Hydrolysis is to just break a bond with water. Okay, and usually you need a catalyst. In lab, you would usually use heat and an acid as a catalyst. In your body, you use an enzyme. So let me show you an example of hydrolysis. Let's say you have a molecule like, for example, lactose. Lactose is a sugar. It's a disaccharide, and you'll be seeing it in next week when we do carbohydrates. Lactose is made up of two monosaccharides, and they are glucose and galactose. So you have a galactose, and it's bonded to a glucose. All right. In your body, those of you who are not lactose intolerant, lactose is digested, it is broken down, it is hydrolyzed using the enzyme lactase and a molecule of water, okay? And then, so what we do is we say plus water, HOH, and we've got an enzyme called lactase. Those of you who are lactose intolerant, that's the enzyme you are missing. And we'll talk more about this in the carbohydrates chapter. But right now what I want to do is I want to show you that this water molecule, and with the help of the enzyme, breaks this bond. So it breaks the bond between these two. So lactose is galactose hooked up with glucose. When the water comes in, it breaks it, and then you end up having free galactose and free glucose. So hydrolysis will break bonds. It will break an ester bond. So let's say I have an ester. Let me take this away. Here's an ester. Remember what an ester looks like. O, and here's my ester. The carbonyl O is an ester. You put water, HOH. All right, so this is an ester. You're going to add water. You're going to add an acid and heat, or if it's in the body, it'll be an enzyme, will be the catalyst. So you'd say acid plus heat. And then what will happen? You're going to break the ester bond, and you end up with the original things that made up the ester. Do you guys remember what those two things were? Because this hydrolysis is the reverse of an esterification. So esterification, remember what we did? We removed a molecule of water and we put an alcohol and a carboxylic acid together to create an ester. But now we're doing the reverse. We're breaking the ester bond using water. So basically think of it as breaking this, putting an OH over here and an H here to form a carboxylic acid and an alcohol. Carboxylic acid and an alcohol. So This is an example of hydrolysis. All the digestive enzymes, you've heard of the enzymes pepsin, trypsin, chymotrypsin. You have maltase, lactase, amylase, sucrase, all the digestive enzymes, all of them, they all catalyze or speed up hydrolysis reactions. So if I ask you on a quiz or a test, give me an example of a hydrolysis reaction, what is it? It's basically using water to break bonds. What is an example of that? You could say any of the digestive enzymatic reactions are examples of a hydrolysis reaction. Or you could say hydrolysis is also the reverse of esterification. If you start off with an ester and you add in an HOH with a catalyst here, acid and heat, these are considered catalysts. They'll speed up a reaction. And the body enzymes are our catalysts. In a lab, we just use acid and heat to speed up a reaction. It will break this ester bond, and then you end up with the original carboxylic acid and the original alcohol. Okay, so those are examples of hydrolysis. Let's move on to the last category of reactions, and these are acid-base neutralizations. So basically, if you remember from intro chem, anytime you have an acid and a base, acid is acidic, base is basic, base has a high pH, acid has a low pH, if you remember any of that stuff, you put them together, you get a neutral salt. So if you remember from intro chem, a lot of times, not all the time, but acid plus base will give you a salt and water. Okay, that's your acid-base neutralization reaction. Sometimes when you digest your food, you know that you put it in your mouth, you chew, and then it goes into your stomach. Most of you, I think you all know that the stomach is very acidic, like we're down pH range in the 1s, okay? And the enzymes in the stomach work beautifully at that pH. So they work very well. They love the acidity, the hydrochloric acid and all the enzymes. Everything works great in the stomach. But then everything you just ate has to leave the stomach and enter the small intestine. And the small intestine enzymes, they only work at a pH 7 or a little higher. When you're pouring all this acid coming in from the stomach into the small intestine, those enzymes wouldn't work at an acidic pH, in a very acidic environment. So what do you have to do? You have to neutralize all this acid, and that's why we have bicarbonate, which is a base, and it will come and neutralize the acid, all right? And then you get a more neutral situation. All right, the practical application of this is a lot of medications. Now, you know that your body is mainly water, right? And a lot of medications that they make, the drug companies, a lot of them are amines or amides, many amines. Many of them have nitrogens in them, amines. Well, amines are bases, okay? And amines in a medicine, great, it works very nicely, but when it gets into your body needs something that will dissolve in the blood, right? So it needs something that is water soluble. And amines are not as water soluble as a salt would be. You'll find out as we progress on in the semester that salts have a charge. The actual definition of a salt is an ionic compound that doesn't have an OH in it. So do you remember ionic compounds? Sodium ion, chloride ion, they come together to form sodium chloride. This is an ionic compound. Okay, the cool thing about salts is that it has charges, and so they're very water soluble. They're polar and very water soluble. So a good use of this acid-base neutralization You see it in medications. What they'll do is they'll take a drug that has an amine in it, and they will throw in an acid, and then the acid and the amine, which is a base, form a salt that has a charge. It becomes soluble in your bloodstream. Let me show you what that would look like. So here's my amine, okay? Let's pretend that this is some hypothetical, I'm just going to put an R, hypothetical drug, okay? This drug is something they want you to take, and it's very good medicine, all right? But it's not soluble enough in water, all right? Especially if there was another carbon here. Let's say put another carbon here, all right? So what do? They add hydrochloric acid. So this acid, there's a lone pair here. The hydrogen ion comes here. You don't need to know all the details, but I just wanted to quickly give you an example here. What I need you guys to know is to just be able to recognize that what I'm doing here, this H comes here, forms a bond with this lone pair, and now this has a charge like an ammonium ion, and now all of a sudden this drug that wasn't very water soluble, because they added an acid to it, now it formed a salt, and salts are very water soluble. All right, so acid-base neutralizations give you a salt. They also neutralize either the acid or the base to come at more of a neutral pH. And salts, what I want you to know is that salts are more soluble in water than the original acid or the original base. Okay? All right, so that wraps up all our reactions. My last video will be a recap of all the reactions, and then I'll give you a couple of biochemical pathway reactions, and I need you guys to identify which category of reaction. Is it hydrogenation? Is it hydrolysis? Is it esterification, etc., etc.? Okay, so I'll give you those instructions in the next video.